So if you have, so let's say we have here an OR group. So adding a Grignard to an ester, all right, you usually add 2 equivalents of the Grignard. All right, well here, yeah. So let's say we add methyl Grignard. And then your second step is any acid. So what you get, here, let's do the Grignard a different color, just so that we can see what happens. CH3. So your final product is this. All right, you basically add 2 methyl groups and you form a tertiary alcohol. All right, so what happens in the mechanism, just so you can understand it, is the first equivalent of your Grignard adds in here and kicks up your pi bonds, and you form this intermediate. Okay. And then what happens is the electrons from the negative charge pop back down and kick out the R group. All right, because this is acting as a leaving group, which we'll learn in chapter 10. So that OR group completely leaves, and you now form this ketone molecule with one of the methyl groups there. So if you only had one equivalent, this is what you form. You actually stop at the ketone. All right, if you only have one equivalent of the Grignard. What the second equivalent does is it adds it again, and just like what we learned in this class. You have a second one now, or in this chapter. You have another one that adds in, and you form the negative charge, and then when you add the acid to it, it protonates your alcohol. All right, so it does the same type of reaction. It still attacks the carbonyl, but if you have an ester, if you have an acid chloride, if you pretty much have anything from chapter 10, with the exception of a carboxylic acid or amine, which we'll learn in chapter 10, this group actually can leave when you add a nucleophile. So it's basically a substitution reaction. The first step, that technically is a substitution, because you are substituting a methyl group for an OR group in order to get the ketone. So that's basically what happens when you add it to an ester. But we definitely will talk more about this in chapter 10, but I guess since they kind of mention it in chapter 9, I have no problem going over it. You'll just see it twice. Yep, no problem. You're welcome to do. That'll be a way to... Oh, there it is. That's how you do it. Yeah, let's get all the colors. Let's get the dark green, put right there. There we go. Let's get this black. Let's put right there. Yeah, so we got colors right there. Little things in life. So happy. Let's get a yellow too. There we go. So now I can just click on those and I got my colors. All right. Perfect. All right, let's go. Okay. Any other questions before we do some problems? Can you go over the difference between a 1,2 and a 1,4 again? Sure. All right. So, if you have, remember, this uses an alpha beta unsaturated carbonyl compound. So you have to have a double bond, and attached to it you have, you have a carbonyl, and then attached to it you have a double bond. And you count starting from the oxygen. So let's use one of my new things I just did here. There's 1, there's 2, that carbon, 3, 4. So if you have a strong nucleophile, remember, a strong nucleophile is one that has a negative charge. These go 1, 2. So like a Grignard, LAH, whatever. If you have a weak nucleophile, remember a weak nucleophile has a hydrogen instead of a negative charge. These go 1, 4. These are going to add right there. All right? So if you have the strong nucleophile, that's your compound. If you have a weak nucleophile, or your product, that'll be your product. If you have a weak nucleophile, that will be your product. All right? Yep, no problem. All right, anything else? I like the lighter purple, I think. All right. Good. Anything else? I remember there's a way. I think this should work. Hopefully this works. Yeah, this should work. I don't remember. Did I tell you this class about Jing? Jing. It's this program. It's a free program you can get. You can copy any part of your screen. You can also do little videos too. I think they give you like a 5-minute limit video. So you basically, you see I have the cursor, and then you can copy whatever you want on any page, copy it, and then you can go to any type of other program and you can paste it in there, just like that. So it's kind of I think I got a long time ago, and back then it was free. It probably still is free. So kind of cool. I remember there was a way I was able to do this yesterday. I was trying to figure out. I couldn't do it. So. Okay, so there we go. Work on this problem. I don't think we did this one yesterday. I think I wanted to, but we ran out of time. So do this problem. Fill in your reagents, and then we will go over it. I want to see if there's another problem, but I think basically we'll start doing synthesis problems. That's it, yeah. All right, so I'll give you guys a little bit of time to work on it. All right, so first reaction. Notice we're obviously adding this group right here. All right, the aromatic ring, plus we're getting an alcohol. So anytime you make a carbon-carbon, we're making a carbon-carbon bond. Plus, we're making an alcohol, that's a Grignard. All right, so obviously the carbon group that we're adding is going to be the Grignard. So A is actually a two-step reaction. The first one is adding the benzyl Grignard. Or phenyl, it's actually the phenyl Grignard. And then the second step is adding acid. Just remember you have to protonate your oxygen afterwards. So that's going to be A. All right. Oh, erase the whole thing. Well, it doesn't matter. We're going after the next one. All right, then the next one. So we're starting. Let me rewrite it. We're starting with the alcohol. All All right, and we're going to a ketone. So from an alcohol to a ketone, we are oxidizing. So the oxidizing reagents, you can actually add any one of the 4 reagents that we learned. So either PCC or PI, because we're going because it's a secondary alcohol, or you could have added the Na2Cr2O7 in acid, or the CrO3 in acid. Either one of those, any 4 of those in this case would work. Okay, and then so that's B. And then C, notice we're putting a bromine on. Notice it's going meta because we have a pi bond adjacent to the aromatic ring. So that's chapter 5 reaction. So Br2, and you got to do that in iron bromide as your catalyst. And then D, notice we have the, remember that is called the acetal. That's an acetal. So the way you do an acetal is 2 equivalents of the methyl alcohol. If you put the 2, that's fine. If you didn't, not a big deal, because your book kind of does both. And then you have to put acid in it to make the acetal. Okay? Any questions on those? You know how much I like these. I put stuff like this on exams. Okay. Good. No questions. Let's move on. Let me just see if there was I don't think there was any other problems. I think we got through pretty good examples of all the problems with reactions, some synthesis, some mechanisms. Actually, you know what? Let's do 42. Just because acetals sometimes can be confusing. So I want to make sure you guys really get those. However, let's not do A. We don't have to do A. Just do B and C. All right, there's 2 different ones there. All right, so basically show the structure of the alcohols and aldehydes or ketones that you would use to make the following. So these are your products. Okay, so this is your product. So here's your product. Show me what you start with in order to make that. And the same thing for the one below it. Here's your product. Show me what you use to make it. All right? All right, guys. All right, so the first one, basically just look at the 2 oxygens and whatever groups are attached to it. That's your alcohol. All right? So in this case, your ketone will look like that. And then 2 equivalents of the CH3, CH2OH in acid. Okay? And then for this one, that was a little bit trickier. I'm going to draw it differently so we can see a little easier. I'm just going to turn it sideways. All right? I'd be thinking those 2 rings there. It looks a little weird. Well, remember the carbon that has the 2 oxygens attached to it, that's where the carbonyl was. All right? So I have a carbonyl on this 5-member ring. All right? And then your alcohol, so your alcohol, this oxygen and this oxygen are alcohols, but they happen to be attached to each other. So the alcohol in this case, it's a diol. Because remember, you need 2 alcohols. Well, you actually only have 1 compound, but there's 2 OH groups on it. So that's the alcohol in that case. This is actually a very common reagent to use as an acetal. I had a student once call it a Bart-Simpson reagent because I like that. Maybe it was a little bit like Bart Simpson. I don't know. I guess I can kind of see that. Here's his hair. So, all right. So any questions on that one? That's why I kind of wanted to go over it. Just make sure you understand, what the alcohols are. Yeah. So on that one, on the Bart Simpson one, it's only one equivalent, right? Because it's not really how many equivalents of your reagent you add. It's how many OH groups you have. So in order to do this, you need 2 OH groups. That's really how you should look at it. In this case, I have the 2 OH groups. They just happen to be attached onto each other. It's 2 OHs that you need because you're adding these 2 oxygens, right? So in this case, they're separate, but in this case, it's on the same molecule. Yep, no problem. All right, good. All right, so let's now do some synthesis problems. Okay, so these are chapter 10. We're going to start off a little bit easier ones, smaller ones that require maybe like 3 or 4 steps in the synthesis, and then we're going to start getting a little bit more advanced, get more steps into it. All right, so I'm going to write here what the starting material is. All right, and through a series of steps, I want you to make that compound. Okay, so start here. So again, I always tell you guys, work backwards. Always go backwards. They'll help you kind of do it. Okay. So I'll give you guys a little bit of time. Let me know when you're done by typing into the box when you guys are ready. All right. So start with an alcohol, PCCPI, to get the aldehyde. Then you have to get this alcohol. Notice this alcohol is on the least substituted carbon. So if you look at your starting materials, we can go from a double bond to an alcohol. But the important thing is to realize it's going on this carbon right there, your least substituted carbon. So that is where you have to use the anti-Markovnikov. All right. So this is just a 2-step synthesis. Okay. Any questions on that? Now, if you said acid and water, that would not be correct, because acid and water, remember, goes to the more substituted spot. In this case, you specifically have to go to the anti-Markovnikov, okay, with the BH3. Any questions on that? All right. Let's do this. Start with a double bond. And this time you're going to synthesize this compound. All right. I look the same, but it's not the same. So I'll let you guys work on that for a little bit. All right. So again, going backwards. PCC or PI, whichever one. That's 3 carbons. Okay. At this point, you should start thinking about what reaction do I know that takes off a carbon, and that's the oxidative cleavage reaction. So chem205 and acid. And the thing you have to remember is that it leaves a carboxylic acid. It doesn't leave the aldehyde. All right. So that's the reaction you have to do first, because you got to take off a carbon. Anytime you see your product has less carbons than what you're starting with, this is the reaction that you have to go through. If you have more carbons than what you start with, then you're probably going to do a Grignard or the acetylide reaction that we learned in chapter 4. Okay? So those are kind of the hints, depending on what you're doing. If you're losing carbons, you got to do the cleavage. If you are adding carbons, you got to do the Grignard. Okay? Now, there is no way to go from an acid to an aldehyde. So you got to go from the carboxylic acid straight down to the alcohol with LAH. You got to use LAH in this case. You can't use sodium borohydride because you have an acid to an alcohol. And then go ahead and oxidize that. Okay, does that make sense? So those are types of things that you're looking for. If you're losing carbons, you got to cleave it. If you're gaining carbons, we'll do some Grignards, which we will do a bunch of those problems too. All right, any questions? All right. Another one. Let's see what we got here. Yeah, that's a good one. We will. This is your starting material. You can use any other reagents, and I want you to synthesize that compound, that ketone. All right. So start with cyclohexene, and then end up with the cyclohexyl methyl ketone. Oh wait. So why was it LAH? Because I did. So the CrO3 is an oxidizing agent. It's not a reducing agent. All right. So since I was going, I had a carboxylic acid, and I was going to the alcohol. All right. If you're going from the alcohol to the carboxylic acid, that's when you use the CrO3. That's oxidation. I'm not oxidizing. I am reducing here. So I got to use one of the reducing agents, which is either LAH or the sodium borohydride. And since we're going from an acid to an alcohol, I have to use LAH. All right. So Anna, that question you asked is a common one. A lot of people get all confused when you use the CrO3s and the PCCs and the PIs versus when you use the LAHs and the sodium borohydride. All right. If you want to oxidize, these are your oxidizing agents. If you want to reduce, these are the reducing agents. So to go from an acid to an alcohol, I am reducing. So I got to use one of these reagents. But in this case, since it's an acid, I got to use LAH. Okay. If I was going the other way, like I said, from alcohol to the acid, then I'm oxidizing it. So then I would use that CrO3. Right? Does that make sense? Yeah, no problem. And it's common. It's like, all right, I know I got these reagents, right? Am I reducing? Am I oxidizing? It happens a lot. So it's something just to be aware of. What do you do with bulk? I want to write. So why can't I clean that? Oh, actually. Do a bulk erase. Backwards in time. All right, there we go. All right, I'll let you guys work on that synthesis. And again, let me know when you guys are ready. Okay, so double bond. Then we have a ketone. And notice I added carbons onto here. Okay. So, first of all, by going backwards, go backwards. All right. Notice I have a carbonyl. The way you make a ketone is by oxidizing an alcohol. Okay. Now there's lots of different ways of doing this. Hopefully you did it using the newer reactions. I forgot to mention that. I want you to do this using newer reactions, not just Chapter 4 reactions. Because there is a way to do this with just Chapter 4. If you did it that way, it's great. But on this going around exam, I would say you have to use reactions from Chapter 8 or 9, or 9 or 10 or whatever. But I'll show you all the possible ways. But this is kind of the way that I wanted you to try to do it. At least try to get reactions from the newer chapters. All right. And then to get this alcohol, you can do that from a Grignard. So you can add, we'll take this Grignard. Let's put a chlorine this time. And then you can add it to this. Second step is adding acid. And to make this Grignard, you got to start with the alkyl halide and add magnesium, and then HCl. All right. So that's kind of the route I was trying to get you to do. Like I said, you could do this Chapter 4. What you could have done was added the acetylide reaction. Again, this would work, but I'm going to be more specific on this going around exam, saying you have to use reactions from chapter 9, or you have to use at least some reactions from chapter 8 or 9, and then adding the mercury and acid. So that's just using chapter 4 reactions. Okay. Any questions? Anyone do something different and they want to discuss what they did and see if it works? Because at this point, there are several different ways of doing things. Probably not much different with this one. Anybody have one they want to go over that they did? You can unmute if you want, or... Oh, okay. I'm going to delete this if everyone's got it. All right, let's see. Let's do another. Oh, let's do this one. Let's see. All right, this one you have two different reagents. All right, so here's your product. Let me give you your product. All right, let me make this look a little bit better. All right, I don't know if that looks better. Here's your product. You have two different reagents that you have to use in your synthesis. Okay, one is this carboxylic acid, and the other one is this diene. Okay, you're going to show me how to use those in the synthesis of this compound. All right, now when I have two different compounds, it's basically two different mini synthesis problems. It's kind of like, here, I'll kind of show you how you should think of it. I just can't get that. What's that? Dry mode? This blue one. So what you kind of have to do is, like this compound, you'll have to do a few reactions to it to form something. And then this compound, you have to do a few reactions to it. All right. And then eventually, and you'll have a compound. And then eventually, somehow, these two will have to all come together, you know, and eventually form our product. So it's kind of like it's two different things. If I'm giving you two different reagents, so it's basically every carbon on your product, has to come from these two molecules. You can't just add any carbon-containing compound you want, right? You have to make them from what you're given. All right, so hopefully that makes sense. You have to somehow show me how all of this fits all together. Okay. All right, so you have two different compounds. You have to kind of show me, you know, obviously I would go backwards. So first thing is show me what the last reaction is. All right, and then from there, so here, I'll give you a hint. It'll be some compound plus another compound. And then from there, this will go backwards eventually to maybe form that compound. And then this one, you'll go backwards and show me how to go from that compound. All right, so does that make sense? There's two different compounds. You have to kind of build them up in a certain way, or at the final, you'll have two compounds and you put them together to form the final compound. So I'll let you work on that. The last step, so remember, always do the last step first. And also, again, remember, I mean, obviously, adding the two products together, I don't know. Oh, okay. So notice we have an ether. Ether is the functional group. So what the trick is always to look at the functional group, put ether down here, and try to find which reaction makes that functional group. So the only reaction we learned was the Williamson ether synthesis. Does that sound familiar? Williamson ether synthesis. It was the last chapter. It was an SN2. I said, you guys already know this. It's an SN2 reaction. Does that sound familiar? So look up the Williamson ether. That's the only way we know how to make it. It's basically an SN2 mechanism. All right, give you guys a little bit more time. All right. Okay, so the last step, like I said, is going to be the Williamson ether synthesis. Let me get this out of the way. All right, so I'm forming the ether. So the question is, where do I form? Do I put the alkyl halide here, the alcohol here? It doesn't really matter because you can form it either way. So however you did it, you can do it the other way. So if I do it the way you didn't do it, you can do it the other way too. So I'm going to make this the O minus, and then I'll make this the alkyl halide. Okay, so that's how you make ethers. Ethers is just the SN2 reactions. You have to have a strong nucleophile, in this case the alkoxide, and then you add it to an alkyl halide. I just put a chlorine, but you can put bromine or iodine, and this just does an SN2 reaction, and you form the ether. Okay, so I have to get, this is the two compounds I have to get to. Okay, so you can see that this compound obviously is going to come from this compound, and that can actually be in one step. So you're going to take this double bond, add HCl to it, and you can make the compound. You can also make it into the alcohol and then add HCl or SOCO2. That's fine. That's an extra step. You don't have to do it, but if you did it, that's totally fine. Okay, so now the problem becomes is taking this compound and synthesizing into this O minus. So just again going back a step at a time, to form the O negative, we learned that you can add either like sodium metal or you can add like sodium hydride. Either one of those, but it has to be on this alcohol. All right, and then now it goes from going from here to here. And again, what you should notice is that there is a carbon missing. You've got two carbons here, 1, 2, and here you only have 1. So kind of the same thing is going to happen as we did last time. You're going to have to cleave it. So so you can tell there's going to be a lot of different reactions you got to do in order to get it into that alcohol. So let me erase this because we're going to need some room. Okay, so you know that you're going to have to cleave it. So that kind of hints to you, okay, if I cleave it, that means I'm going to have a double bond there. So I have to get to that double bond, right? Because I need to cleave this. If I take this and add the chem205 and acid, it cleaves it, makes the carboxylic acid. Then I can add LAH to it and reduce it down to the alcohol. Okay? So then, now my synthesis becomes trying to synthesize this compound, that double bond. So in order to get a double bond, there's two ways. It's an elimination, but by looking at this alcohol, the carboxylic acid, if I reduce it down to the alcohol, I then can add acid. And guys, this is a tough one because there's a lot of different steps. So that's why I wanted to start synthesis so that we can start working on these. Then you add acid and heat. All right, so this molecule is easy to make. But then I had to make this thing, and notice there's a pretty lengthy, there's a 1, 2, 3, 4, 5 reactions just to get to the compound I want. All right, but notice it pretty much uses almost every reaction from the past chapter plus the chapter 4 reaction. I kind of gave this because we talked about this in another synthesis. All right, so I was hoping you saw that you have to get rid of one of the carbons. Oh, that has to be elimination, so that means I need to get a double bond right over here. All right, that makes sense? If you got it, that's awesome. If you're almost there, that's good. If you're still struggling, it's all right. You just, we'll just keep working on them. Okay, but the real trick thing is backwards. But notice I was going backwards, but then I also realized, wait a minute, I know I have to make this compound. I knew I had to make that because I have to cleave it. And the only way to cleave is with a double bond. So I kind of knew this compound was kind of in between this part of it and this part of it. So I basically had an anchor to help me bring all together these two pieces. Okay? Any questions on that one? Is it quiet today? Let's see what other reactions we got here. Okay. All right. Any questions? So let me see another problem here. How do we do that one? I guess we can do this. Synthesize. And do that. And the two compounds you have to use, it's the same type of thing. You're going to be using these two, and then you have to piece them together somehow. Those two compounds. Oh, wait a minute. No, there's something that should be here. Hold on. There. All right. So you got to somehow show me how these two compounds come together through a series of reactions to make this final compound. All right. Okay. Put you guys on pause and come back when we're ready. All right, guys, let's go over this. All right, so the one thing you need to look at is what really helps is what part of your final product comes from the fragments. Okay, so what I like to do first is count the carbons and see if I have the same number of carbons, if I have to take away carbons, if I have to add carbons. So we have the aromatic ring plus 2 carbons here, plus another 2 here, for a total of 4 carbons hanging off my chain, and that's what I have. So I don't have to add, I don't have to cleave anything, I just have to somehow attach this piece onto my molecule. All right, so obviously these two, let's count these as 1 and 2, are these compounds, 1 and 2. And then these carbons, 3 and 4, would be carbons 3 and 4. All right, so this piece of it is going to be my double bond. And then obviously this piece of it is from the aromatic with a double bond. All right, so I'm basically hooking this carbon to this carbon right here. All right, so it's basically I'm making this bond right here. That's the carbon-carbon bond I'm making. So carbon-carbon bond, I have to make a carbon-carbon bond. That's a Grignard. All right, that's screaming to you, Grignard. And then I have a double bond. Well, if you remember, a Grignard not only adds carbons, but it also makes a double bond. I'm sorry, an alcohol. So a Grignard makes carbon-carbon bonds, but remember, it also can make an alcohol. And we know, we've seen a few times today, and we've learned that you can take an alcohol and eliminate it to a double bond. So the strategy is going to make the Grignard, which makes the alcohol, and then you're going to eliminate that alcohol to make the double bond. All right, so the way to do that, let me get my eraser here. I got to figure out how to do a way to erase this without having to do this every time. Just select what I want, delete it. It didn't work with the other one. I got to figure it out. Okay, so by going backwards, based off of that, if I had my alcohol on this carbon right here, remember alcohol, when you eliminate, goes Zaitse's rule, follows Zaitse's rule. So if I have the OH right here and add acid and heat, you know, I can either go this way to make the double bond or this way to make a double bond. All right, but based on Zaitsev's rule, I'm going to get the more substituted position. So if we count these carbon 1, 2, 3, 4, I want it between the 2 and the 3. Okay? So that's basically the planning stage. You kind of have to think about how you have to plan these. All right, where the groups have to go, knowing we have to do Zaitsev's rule, and or Markovnikov, and this and that, and all that stuff. Okay, so then I go backwards from here and think to myself, okay, this was the Grignard, all right, because remember, Grignards attach carbons and make alcohols. So I'm obviously making this bond right here. That's the bond I'm making because here's my 2-carbon fragment, which comes from that thing, and then here is the other piece of it right there, which is coming from there. So if the oxygen is on carbon 2, that means that's where the carbonyl has to be. So I'm going to be adding this compound. And then the Grignard is going to be the part on the aromatic ring. So 2 carbons plus MgCl. So those are the 2 pieces that I need. Okay? Everyone follow me so far? Make sure you guys are following me. Yep, okay, good. Okay. So, I'm going to have to, I need more room here. Let me just get a new page. Well, let's just do. Oh, that just does it really quick. That's not what I wanted. All right, let's keep it here. Okay, so first, let's do this compound. So that compound is going to come from the alcohol, and I have to oxidize it with PCC. And then to get to this alcohol from here, you basically just add acid and water. Okay, acid. If you did anti-marks, that would work as well. So if you want to do that reaction, in this case, it doesn't matter, it's equal. So basically make the alcohol, oxidize it to the alcohol. This obviously is going to be a little bit more complicated. Actually, I have room down here. Let's do it down here. So to make this Grignard, just going backwards a step at a time, to make a Grignard, you got to start with the chlorine and add magnesium. To make the chlorine, you got to, so remember, notice this is anti-Markovnikov chlorine. All right, because remember our compound that we're starting with is this compound right here. If I were just to add HCl to this compound, the chlorine would go on carbon 1. Okay, so if you just add HCl to it, you get the wrong chloride. You have to get it at this position. So how do you get a chlorine at that position? Well, you have to start, the only way we've learned how to do anti-Markovnikov is with the alcohol. So you got to get this alcohol, add SOCl2, and get the chlorine there. Well, to get this alcohol, you got to do the anti-Markovnikov on the starting material. So the first step is BH3. The second step is H2O2 and sodium hydroxide. All right. These are pretty intense synthesis problems. All right, but that's why we're practicing them. Okay, so what I would recommend you do, it's pretty much our day. What I recommend you do is you redo these synthesis these problems again. Don't have the answer in front of you, just have the synthesis problem. I might be thinking, well, I already did this problem. I kind of know it. Well, the thing is I hope you're starting to see that the same reactions are coming up over and over and over and over again. We're doing anti-marks. We're doing Markovnikov stuff. We're doing oxidations with PCC. We are turning alcohols into alkyl halides. We are making Grignards. We have to try to figure out where the Grignard is. But every problem we've done so far pretty much uses the same types of strategies. So even though it's the same problems, it kind of helps you with the strategy. Okay, so even though it's the same problem, you still will think the same strategy. So if you see a new problem, which we will do a lot more new problems, plus if you go to our, if you go to our, let me just show you real quick. If you go to D2L, oh, here's the problem. No, I guess I delete the problem sheet. I should post the problem sheet. I only have the answers up here, but I'll actually post the blank ones. If you look at the end, all right, actually, let me pull up the sheet that I'm going to post to you guys. I'll post this as soon as we are off. I thought I posted these, I guess. There's so much going on, I forget to do a lot of stuff these days. Let's see, chapter 9, page, I think it's page 3. So I gave you tons of synthesis. So this whole page is just a whole bunch of synthesis problems. All right, I have 1, 2, 3, 4, 5, 6 different synthesis problems. I don't think these are ones that I gave in class. No, these are all different ones, but they're very similar. Okay. So here's your starting materials. Here's your products. Okay. So again, you know, you're going to be like, just to show you real quick. Notice I'm adding 2 more carbons, so that's going to be a Grignard. Notice I have a carbon here on my aromatic on the cyclohexane. I don't have the carbon anymore, so that's kind of showing you I'm taking away a carbon. So these things should be kind of starting to look familiar. Things that you know, it's a different problem, but yet the strategies are the same. Also, make sure that you realize that you got to use chapter 8, chapter 9 problems. Okay. Okay, so with that said, oh, I got a question here. All right, sorry about that. Question starts from the first synthesis. Oh my goodness, I don't know if I remember what it was. How did you get the anion when you went from OH and then added sodium? And then, oh yeah, I don't recall adding sodium to get an anion. I'm drawing a blank. Okay, yeah, so this was, let me see where we talked about this. This was chapter 8. Chapter 8, we talked about how you make strong nucleophiles. I kept saying, you know, we use these strong nucleophiles, but how do we actually make them? So chapter 8, let me get you a section. So you can, it looks like 8.5, section 8.5. I don't remember if you were there on that day in class or not, but I think you were here almost every day, so I think you would have been. It's when we talked about the Williamson ether synthesis. Okay, if you take an alcohol and you want to make it into an O negative, and remember, O negative has to have a counter ion. Usually it's a sodium ion is our counter ion for it. So you can't just have a negative by itself. So in order to do that, you can either add sodium metal, we looked at it as a solid, or we also saw an example where you can take sodium hydride. All right, we talked about how if you take water and add sodium metal to it, that's how you form sodium hydroxide. And you also form hydrogen as a gas, hydrogen gas. And this reaction is exothermic. In fact, it ignites the hydrogen, and you have this flame of hydrogen above water. So in Gen Chem, you usually learn about that type of reaction. This is kind of the same thing. You just take an alcohol plus sodium hydride, or sodium hydride, and you can turn it into a negative charge. You can also have a sulfur here, if you have SH, and then you form the RS minus. Or you can have an amine as well and add sodium or sodium hydride and get NH with a negative charge. Okay? So like I said, that was chapter 8. And I see in my notes at 8.5, well, there's a bunch of chapter 8 synthesis problems too. I think we'll kind of do those. Okay, you remember now? Okay, good. There's some chapter 8 ones also. And then next week, I'll talk more about quizzes and the exams, but the more I think about it, the more I think we are going to do one chapter exams. Just to stay on schedule, I am really thinking, just to let you know, that our first exam might be next Thursday. So a week from today would be an exam just on chapter 8. Okay, so keep that in mind. I'll see how everyone's feeling about it, but all right, just to stay on schedule. I want to try to plan to start doing these probably every week to almost every other week, because we have chapter 8, chapter 9, chapter 10, possibly chapter 12 as well. So we got 4 chapters, and we have like 5 weeks left, I think, in the semester. So based off of that, we got to be doing a chapter every single week in order to stay on schedule with all that stuff. Okay, but I'll talk more about it next Tuesday. But in the meantime, make sure you're staying on top of this. Like I said, if we do have an exam next Wednesday, you should be making sure that you at least get on top of chapter 8 material. Okay? Any questions? Anything else? Otherwise, we'll call it a day. Good job, guys. It'd be Thursday. It'd be next Thursday. Yeah, because on Tuesdays and Wednesdays, I need those days for lecture of stuff. So if we start doing exams and stuff like that, it'll have to be on the Thursday of that week, because that day, is open for problems. And what we would do is only have an hour for it. Yeah, I don't think I'll monitor it, but it'll only be for an hour, since it's only one chapter. And then we would still have a Q&A for any chapter that we talk about on Thursday. I probably won't do like the monitoring thing I did last time. That's kind of hard to do. All right. We can talk more about it. How do you have work on Thursday? Because did you keep that open for classes? I mean, we still have classes. I guess I would have to talk to you separately. I mean, I imagine everyone's work schedules have changed, but I'll have to talk to you separately about that. All right, that's it. I'll talk to you guys later.